Hello everyone. In this session, we are briefly going to discuss about the series data structure within Pandas. We earlier have learned about the data frame data structure, which essentially is two-dimensional in nature. There were both row indices as well as column indices. So we also have drawn an analogy in between series versus what we have observed as columns in the data frames. So every individual column reference that we have made for a given data frame are nothing but the series objects. So individual series objects together can be assumed to be a data frame. That's what we have learned in the previous session. Now let's consider this particular customer DF data that we already have defined in the previous session. Let's also reference any of its columns like gender by providing the column name within the subscript notation. Now you clearly observe that all the values that are provided within the result are nothing but the values that correspond to this column called gender. We also observe the respective indices for every single value that's resulted for gender column. You can reference any of its values by providing the index value. Let me provide index value of 3. Now you will observe the resultant value to be M. You can also provide 0 colon 3 in order to provide or display all the first 3 different values pertinent to the series object. 0, 1, 2, 1 and 2 are being printed out. You always know that the ending index is always excluded from the result here. So this here, if you check the type of it, this type here is going to be series. So this is a series object basically because it is belonging to class series. So likewise, any column reference that you are making is nothing but it's a series object, and you clearly can understand from the type of it that the object belongs to class series, or it's an instance of class series here. Okay. Other than these regular method of inferencing a given series from a given data frame, you also can create a series object by using td.series class. And within this parenthesis, you can provide a numpy array, which is one dimensional in nature. So np.arange of 10 is going to generate all these values starting from 0 to 9. And this clearly here is a series object. And you can assign this to ser1, and you always can check the type of this newly created series object so as to make sure that whatever you have created now, whether it is a series object or not. Okay. So just like you have done indexing operations for this particular customer DF age reference, age column reference, you also can do the same style of indexing like 0 colon 3 to generate these first 3 values pertinent to the series object. You also need not provide anything, just provide colon colon. It's going to result the complete values that are part of this particular series object. Even a single column would result the complete data here. So colon colon -1 is going to print all of these values in the reverse order. So we have learned about all of these indexing in our lists. So we essentially have implemented all of these methods or all of these best practices that we have incorporated for slicing the data. Even for reversing a particular list or reading the elements in a given list in the reverse order, you always have provided colon colon -1 within the subscript notation. We learned about these positive indices as well as negative indices, more or less resembling the same indexing mechanism that we already have put in place early in Python sessions. Now let's get back to this particular understanding about series. So we were able to create a series object, but we have not provided any name yet. So we have not provided a name for this particular series object, which I am providing now. So name here is going to be sample underscore series. Now you can understand the name is being updated in the result here. Along with name, you also can provide explicit indexing. So whatever indices that you are currently observing are nothing but implicit indices. Like it always starts from 0 to length -1. Length being the total number of values or observations pertinent to that particular series object. So let me write a simple list comprehension in order to define these explicit indices for this series object. So I for I in range of 97 to 107. So why am I providing this specific range of values is what you'll understand. So 97 here is ASCII value for this character A. And hence I would enclose this value within this function called chr in order to convert all of these respective values into its corresponding character values. I'll consider all of this data or all of this list comprehension and use it as index while creating the series object itself. Now you clearly understand that all the implicit indices that we have observed earlier are gone. Whatever indices that we have defined now are applied. You can reference any given value here by using explicit index as well as implicit index. So explicit index B here references to this value of 1, implicit index of 1 within the subscript also references the same value here. You can use both these approaches of referencing any given value. You can also look at slicing this particular data by providing specific set of indices like this. Specific set of indices separated by a colon is always going to result in all of the observations that fall in between those indices. So if I am updating this B to E, then all these first 5 observations are printed out. You also can choose the order in which you need to print out these observations, like internally referencing it as a list. Provide the order in which you need to observe the result to be. So G, comma A, comma I are the 3 indices or 3 observations that I'm planning to display in the result in the specific order that I have defined here. Now the result, if you are observing closely, the result is generated in the same order as that of whatever definition that I have provided. Whatever order that I have provided is in effect now. Okay. So we have learned about the series object and how you create series object and how you draw an analogy of individual column references being the series objects, and collectively you call them as a data frame. So every single series object that you are currently observing, like here, is a one-dimensional array. You can consider it to be a one-dimensional array, but it's not exactly same as that of a NumPy array. It's not exactly same as the one-dimensional NumPy array, because the NumPy array does not have these explicit indices. So all these explicit indices are not referenced in a NumPy array. So this is a primary difference between a series and a one-dimensional NumPy array. So series here is one-dimensional in nature, and data frame, as we have learned earlier, is two-dimensional in nature. You have both row indices as well as column indices in case of a data frame. Cool. Now there are alternate methods in which you can simply create a series object, like by using dictionary. Just like we have created data frame object using dictionary, you also can create a series object by defining a dictionary, by defining key value pairs. I'm providing 3 different key value pairs here. A colon 1, B colon 2, and C colon 3 here. So dictionary 2 has got these key value pairs of B, C, and D. Providing some random values here. So now I have both dict1 and dict2 created. You can simply print out both dictionary 1 as well as dictionary 2. I can also provide these dictionaries within the parentheses while I create an instance of this class called series in order to create a new series object, which I'm calling it as scr_1. Similarly, I can also create a new series object called scr_2 by providing dict2 within the parentheses here. So let me display scr_1 as well as scr_2 here. So now we clearly understand that series 2 has got this A missing out and series 1 has got this D missing out. If I'm representing it properly again, series 1 and series 2 has got all of these indices collectively. Collectively, you have 4 different indices. Series 1 has got a value of 1 for index A, and it does not have any value for index A because index A is not present in series 2, and hence I'm having it as nan. So B has got a value of 2, C has got a value of 3 for series 1, it has got 21 and 13 for series 2. D has got a value of nan for series 1 since you do not observe any index with D. This has got a value of 13 here. So this here is going to be 11. This here is going to be 21 and 13. Sorry about the typo there. And now if you try to add up both these series objects like scr1 plus scr2, now an element wise addition operation is being performed based on the indices that you are observing for both the series objects. So 1 plus nan is going to result in nan itself. So the values for index B is going to be 2 and 11. So it's going to be 2 plus 11, which is going to result in a value of 13. So 3 plus 21 will result in a value of 24. Nan plus 13 will again result in nan here. So now if you try to add up both these series objects that you have created, scr_1 plus scr_2, now you are observing the result just in line with what we have discussed so far. Alternatively, you also can use this method called add. Within parentheses, you provide series 2. It does provide the same result to you. You can also add an additional argument here called fill value, and you fill these missing values with a value of 0 so that your result will not have missing values anymore. So series 1 and series 2 both had these missing values, like so this was 1, 2, and 3 for A, B, and C. This was nan 11, 21, and 13 for index D. This was nan for index D. I am just trying to fill these missing values with 0 here. Fill this with 0 again here. So 1 plus 0 will result in a value of 1. It's going to be 13 again, 24 again, and 13 again. 0 plus 13 will result in a value of 13. That's why we observe this result instead of having nan for both index A and B here. You can substitute any value for fill value here. Let me use a value of 1. Now you are going to observe a result value of 2 for index A, a result value of 14 for index D. Okay. You can look at identifying the different attributes and methods associated with every given series object just by using dir. So this is a regular practice, isn't it? You always can reference the docstring in order to understand more about a particular attribute or method. You also can explore the code itself by providing double question mark and hit command enter or control enter. So as to look at the code, try to understand what functionality that particular code is implementing. Okay. I'm leaving it as an exercise to you to identify various methods and attributes that you might want to explore for series object. Otherwise, you can actually go about referencing any of these attributes like shape. You can also reference dot head. It's going to display top n number of values, n being the value for the argument that you are trying to pass here. All of these different methods that we have discussed earlier would still valid. So whatever methods that we have discussed for data frame are now still valid for series objects as well. Okay. So now we're also going to understand if there are any vectorized operations that you can perform on series objects. So just divide with 2. So this division with 2 is applied to all of its elements or all of its values. You can also raise this to the power of 2. And every single value here is now squared. You can simply go about implementing any of these vectorized operations. It's left up to you. You can add them up or you can multiply, you can divide or whatever it is. All the vectorized operations here are still valid. Okay. We have understood the different ways in which you can create series objects. You also have understood how you can perform indexing on different series objects, how you define explicit indices as well, reference certain values by providing the explicit indices as well as implicit indices. You have looked at performing certain operations using specific attributes and methods. You also have dealt with vectorized operations on given series objects here. You can explore other methods or other methods like series1.keys, which is going to result in all the index values, still valid. ser_1.index also is going to produce the same result to you. You can explore various of these methods and attributes. Please reference the documentation always. Documentation is always going to help us in multiple possible ways. Okay. So that's pretty much all I wanted to discuss with you in this session. And thanks for watching.